Welcome to the Robotics Through Science Fiction podcast, where you can learn about real robots by exploring science fiction. I'm Dr. Robin Murphy, and let's talk about multi-robot systems. They're best illustrated by the 1972 big-budget movie Silent Running, directed by Doug Trumbull, who did the special effects for 2001: A Space Odyssey. Silent Running should be the ultimate Earth Day science fiction movie. It's got realistic robots. They're entrusted to save the world's remaining trees that have been transplanted to space orbitals. Instead of inspiring environmentalists, it literally inspired Mystery Science Theater 3000. Yet, Silent Running is a must-see for any robotics aficionado who wants to learn more, because the robotics is actually quite accurate. The whole family can watch it, but the little ones and pretty much every non-sci-fi fan will likely be bored out of their minds. In a nearish future, the last forests have been relocated to space stations by underappreciative, environmentally reprehensible human race. In effect, we have terrariums in space. Well, the space station terrariums are tended to by three little-legged robots called Huey, Dewey, and Louie, after Donald Duck's nephews. And there's some human misfit astronauts to help out. When the bean counters on Earth tally up the cost of having forests in space that nobody cares about and they can't visit, they order their destruction. Fighting ensues between the jerk crew members who are happy to nuke the forest and return home, and the crazy, gone all Sierra Club to the max crew member Lowell, who wants to disobey and save the forest. And for anyone too dense to miss the pro-environmentalism plot, Joan Baez, yes, the iconic folk singer who is normally very subtly evocative, sings the most overtly cloying Save the Tree song ever. Does it sound like it's a movie worthy of Mystery Science Theater 3000? Why, yes, and it inspired the show. Despite the dose of dreadful earnestness, Silent Running is actually pretty accurate about the robots. The director, Douglas Trumbull, was hot off his special effects work with Kubrick on 2001: A Space Odyssey, and he was all about the technical realism. Maintaining a space station in the harsh vacuum and radiation of space requires robots, as NASA learned decades ago, so bingo, Trumbull put in robots. Good man. And what's particularly accurate about the robots is how Silent Running portrays the multi-robot coordination. Multi-robots offer many advantages over a single robot. They're just things that several robots can do that are different. Like several robots can tackle tasks that a single robot can't do, like moving something heavy, or they can cover more area faster, divide and conquer, or simultaneously divide up and protect an area. And ideally, many robots would be cheaper because of the economy of scale. Writers tend to assume a centralized control paradigm for multi-robot systems, where one computer or robot controls all the robots in a master-slave type of arrangement. And this is particularly convenient for plots where the centralized computer is out to take over the world, like Vicky and iRobot movie. But centralized control of robots has many problems in practice. A big one is that if the centralized controller is down for maintenance or destroyed, say by a young Anakin Skywalker in The Phantom Menace, then all the robots become useless. Hey, joke's on you, Trade Federation. You may be able to control the galaxy's monetary supply, but you made a rookie mistake in robotics. AI researchers and multi-robot systems tend to focus on the distributed control paradigm instead, where each robot has independent intelligence and independent responsibilities. So the distributed controls raise different challenges. One fundamental one is determining how independent you need it to be and what is the minimum intelligence that they need so that robots can get the job done. And are the robots aware of each other? And if so, do they communicate directly with each other, like wolves yipping to coordinate a hunt? Or are they only indirectly aware of each other and communicate through direct perception of the state of the world, or stigmergy? Stigmergy is that biological mechanism where the action of one animal leaves a trace behind that influences the next action taken by another animal. The ants leaving a pheromone trail behind for the other ants to follow. That's stigmergy. A really nice example of exploiting direct perception and avoiding complex reasoning is done by Lynn Parker in box pushing. She had a team of robots push boxes that were too heavy for a big single robot to push. So each robot would start pushing. It can sense whether the box surface was flat to the touch or jutting in or jutting out. If the box was jutting in, the robot would push harder even though it didn't know how many other robots there were or how they were pushing. Just stimulus response. If the box was jutting away, the robot would slack off, thus giving the others time to catch up. And if the box was flat, the robot would just maintain its force and trajectory. Now notice the robots didn't have to know how many other robots were involved and communicate with each other. Plus, it would still work if it was a person instead of a robot that was moving one side of the box. The robot doesn't know or care. Another question that a designer of a multi-robot team has to consider is whether the robot should be the same or different. Identical robots are homogeneous robots working together. They're often programmed to behave as swarms of insects. Now, swarm in robotics implies that the individual robots emulate insect intelligence and have a simple mechanical design so that you can have hundreds or thousands of them, and that would be economically feasible. Huey, Dewey, and Louie were homogeneous, but not a swarm, as each were independently highly intelligent and directly communicated and negotiated with each other as to who did what when. Yet another research challenge is determining in advance how many robots are needed to guarantee accomplishing a specific task. If there are too many robots working on a task, especially if they're acting as an insect-like swarm, it can actually degrade the overall task performance. An example of that old adage, too many cooks spoil the broth. In robotics, that phenomenon is called interference. So how did Trumbull make Huey, Dewey, and Louie? I mean, they seem so natural. And here, where maybe the movie is more appropriate for discussion with older kids, the robots are actually multiple amputees walking on their hands. Really. And notice that when the robots stop to get directions from Lowell or other crew members, they sit down. In a robot, it would be natural to do this to conserve energy. In a person, it was for the actors to reduce fatigue. Likewise, the robots turn slightly to pay attention to the humans walking by, or they turn and move in ways that are consistent with conversational poses and gestures. Is silent running deserving of cult movie status? Well, maybe not for its overall contribution to apparatus theory and film studies, but definitely thumbs up for its cinema verite incorporation of robots. Huey, Louie, rest in peace. Dewey, keep up that good work in that big forest in the sky. And someone, please, please, please put Joan Baez on mute. If you want to learn more about distributed robotics, check out Chapter 17 in my textbook, Introduction to AI Robotics, 2nd edition. If you're looking for books and movies with robots with some science in them, check out the bottom of the webpage of this podcast and topics list on our webpage, and please subscribe and follow us.